3I/ATLAS has just emerged from behind the Sun, and what scientists are seeing is beyond belief. After surviving its near-death encounter with solar fire, the interstellar object appears different. Energy readings, trajectory shifts, and new telescope images hint at something no one predicted. What exactly did 3I/ATLAS become out there? Let's dive right in. When 3I/ATLAS finally emerged from behind the Sun, astronomers went silent. For weeks they had waited for this moment, scanning the blinding glare with every solar observatory available. Then a faint spark appeared near the solar limb. Within hours it brightened, stretched, and revealed itself. The interstellar comet had survived. But something wasn't right. Its brightness wasn't fading as expected. It was pulsing, almost rhythmically. Data from NASA's Solar Orbiter and ESA's SOHO confirmed an unexpected surge in ultraviolet radiation. The energy curve looked structured, not random. That simple detail, a repeating pattern in light, changed everything. Because in space, patterns mean physics or design. Scientists began whispering the same question. How could a frozen rock, fresh from another star system, behave like this after grazing the Sun's atmosphere? Was it natural, or was it something else entirely? And that's where the real story began. As new tracking data arrived, one fact stood out. 3I/ATLAS wasn't moving the way it should. Its post-perihelion trajectory, the path it took after swinging past the Sun, had shifted slightly but measurably. Normally, a comet's course changes a little due to outgassing, when heat makes ice evaporate, pushing the comet like tiny thrusters. But this was different. The change wasn't random. It looked intentional. NASA's Jet Propulsion Laboratory reran simulations multiple times. The numbers held. The object's new acceleration vector wasn't aligned with the direction of sunlight, meaning something else, internal or unknown, was influencing its path. At first, the safe explanation was uneven sublimation of exotic ices, but the emission pattern was too consistent. Some scientists began to notice that the periodic brightening of the object followed the same cycle as its rotational period, as if something inside was regulating energy output. No one dared say it publicly, but in private data groups, one phrase kept reappearing: artificial modulation. Of course, skeptics were quick to respond. Maybe it's metallic reflection, maybe a fractured nucleus scattering light. That's the beauty and curse of astronomy. With one telescope image, you can prove or disprove anything. But what they couldn't deny was the rhythm, an eerie, repeating heartbeat across the void. While debates flared online, a quiet realization spread inside NASA and ESA. Two spacecraft were already moving into potential observation range, ESA's Hera and NASA's Europa Clipper. Both are deep space missions on predetermined courses, Hera heading toward the Didymos-Dimorphos system, and Clipper toward Jupiter's moon Europa. Neither was meant to chase comets, but by sheer cosmic coincidence, their trajectories would bring them near the tail region of 3I/ATLAS during a 7-day window from October 30th to November 6th, 2025. If the comet's tail extended far enough, one of those spacecraft could literally fly through it. That possibility sent a ripple through mission control rooms. The data potential was enormous. Sampling dust from an interstellar object, something born around another star, drifting through the galaxy for millions of years before reaching us. But it wouldn't be easy. Most of their instruments are powered down during cruise. Reorienting them would require commands sent across millions of kilometers, recalibrations, and precious onboard power. It wasn't in the mission plan, but for discoveries like this, exceptions are made. Even a single particle detection could redefine planetary science, an ESA engineer told reporters off the record. We'd be touching something alien, literally. The challenge was no longer if they could observe it, but whether they dared to try. As the days passed, something stranger happened. The Parker Solar Probe, currently orbiting within 10 million kilometers of the Sun, detected magnetic irregularities consistent with an active plasma jet emanating from the direction of 3I/ATLAS. Not strong enough to be dangerous, but far more energetic than expected for a comet of its size. The magnetic signature was rhythmic, repeating at near-perfect intervals, just like the earlier light pulses. At the same time, ground-based observatories in Chile, Japan, and Hawaii began reporting intermittent polarization shifts, meaning the light reflected off 3I/ATLAS's surface was twisting in a way no simple ice-rock mixture should. One theory proposed that its outer shell had developed a conductive crust after the solar pass, possibly metallic compounds formed from extreme heating. Others speculated that the comet was now partially hollow, venting through internal fissures like a pressure system. But the truly shocking idea came from a paper quietly uploaded to arXiv. Given its trajectory and emission pattern, 3I/ATLAS may no longer be a passive body. It could be actively responding to solar radiation through self-induced resonance. Translated, it might be reacting, not just evaporating. That subtle shift, from passive to active, is what turned scientific curiosity into existential intrigue. By October 30th, the tension was global. Every major observatory was locked on the region of space just beyond the sun's glare. Hera was already crossing its projected path. Europa Clipper was days behind, but both missions entered what engineers called opportunistic data mode. For the first time, two separate spacecraft were ready, not to intercept, but to listen. If either crossed the outer plume of 3I/ATLAS, they could capture microscopic grains or trace ions preserved since before the sun was born. The implications were staggering. Did interstellar dust carry organic material? Could it reveal chemistry beyond our periodic table? Or could it show evidence of fabrication, structure, design, or isotopic ratios that shouldn't exist in nature? No one dared say it on record, but among mission scientists, excitement mixed with unease. Because, if the readings showed symmetry or non-random alignment, humanity's first proof of non-natural origin could come not from a radio signal, but from a comet's tail. The countdown was on. 7 days, 2 spacecraft, 1 chance. Now, as 3I/ATLAS drifts outward again, faint but visible, the silence is deafening. NASA's official feed has gone quiet since October 28th. ESA's live telemetry updates stopped the following day. Both agencies cite scheduled maintenance, but the timing is uncanny. Meanwhile, amateur astronomers continue to capture faint fluctuations in brightness, each pulse timed within seconds of the last, like a heartbeat echoing through space. Some dismiss it as coincidence. Others aren't so sure. If 3I/ATLAS truly carries something alien, not a ship, not a probe, but a relic, then maybe this is what contact looks like. Not a message sent to us, but one drifting past, unnoticed, waiting for those curious enough to reach out. And that's where the story stands tonight, balanced between discovery and disbelief. The next images from Hera and Europa Clipper could confirm everything, or nothing. Either way, what's about to happen could redefine how we see the universe and our place inside it. Whatever 3I/ATLAS truly is, a comet, a relic, or something beyond our understanding, it has already changed how we see our place in the cosmos. The fact that it survived the sun's fury means it carries a story we've never told before. And soon, when data from Hera and Europa Clipper finally arrives, we may learn whether that story belongs to nature or to something far older, far stranger. What do you think, though? Is this just another cosmic coincidence, or our first real encounter with interstellar intelligence? Tell me in the comments below. And if you want to follow every new update about 3I/ATLAS and other breaking discoveries from deep space, make sure to like, share, and subscribe to Galactic Breaking News. Because out there, in the silence between the stars, something incredible is waiting.